Okay, so this is another rate of reaction experiment. Now I've picked this one because the way of doing it is slightly different again. Okay, so I'll go through the three different methods, but they're all to do with rates of reaction. Okay, and I'll show you the three different ways they can do it in a minute. So marble is a rock that contains mainly calcium carbonate. It reacts with hydrochloric acid. So you've got calcium carbonate and hydrochloric acid. And then you've got your word equation underneath. Okay, you've got calcium chloride, water and carbon dioxide. Now, the state symbols are not given on this one. Okay, however, we know that carbon dioxide is a gas. Okay, so sometimes you need to, use what you know as well. Most of the time you're given the state symbols, but sometimes you need to remember that. So the rate of reaction was followed, rate, again, speed, okay, so it's something to do with time, was followed by measuring the mass of carbon dioxide formed, okay. Now in this case, they've kind of done it a bit backwards, okay, because they're measuring the mass of carbon dioxide formed. Because carbon dioxide is a gas, it's going to escape out of the flask. Okay, so they've got cotton wool in here that the gas can get through. Okay, but if this is fizzing and spitting anything, the liquid can't. Okay, so the cotton wool helps prevent any splashes or bits getting out. So they're measuring the amount of carbon dioxide being formed by the amount that this goes down. Okay, so you've got 10 grams of marble chips and you've got 50 centimetre cubes of the acid. Okay, so two samples, A and B, were each reacted with 50 centimetre cubed of dilute hydrochloric acid. So this they've kept the same and this they've kept the same. So that's my fair test. So fair is the mass of calcium carbonate, I'll do it in symbols, and also the volume of acid, okay, because we need to remember, well, what do we keep the same, what do we change, what do we measure? The mass of carbon dioxide formed in each reaction was recorded and plotted to produce the graph below. Okay, so they've calculated, because the mass is going down, that's allowed them to calculate the amount of carbon dioxide being given off. And I've got the mass of carbon dioxide here, and I've got my time here. So my time is to do with my rate. So it's the speed again. Okay. Each reaction stopped when no more carbon dioxide was formed. So that's where it levels off. Okay. So it's not producing any more gas, so it's levelled off. In both experiments, some marble was left unreacted when the reaction stopped. So there was some marble that was left over. Okay, so they had excess marble in there. Right, so in terms of what it wants you to do, again, it's just looking at these graphs. So explain how you can tell which sample, A or B, reacted faster. Right, so again, this line is steeper, so that's going to be the faster reaction, and it also levels off first. So there's two ways that I can put. So sample A has a steeper line on the graph, which would get me one of the marks, and also it finishes first because more CO2 gas is given off. Okay, so and again, you could do it in a different way. You could say, right, well, at 2 minutes, B's only given off 0.25 grams, whereas A has given off 0.4 grams. Okay, so that's another way of writing that information. So you pick a time and say, right, okay, well, how much gas has been given off? So you know that sample A is faster. Right, the faster rate of reaction was caused by using a higher temperature. Okay, explains in terms of particles. So I need to use that word, why higher temperature causes a faster rate of reaction. Okay, so we need to think about it step by step. So if it's a higher temperature, then the particles have more energy and are moving faster. Okay, and then it comes on to the bit that's the same for any reason. There are more likely to be collisions between particles. Okay, so that means that it is a higher rate of reaction. Okay, so you've got a higher temperature, they've got more energy, they're moving faster, there's more likely to be collisions, and that will increase the rate of reaction. Okay,